Welcome to this video lecture on the topic Design Thinking Approach to Directional Couplers. So our problem statement is the detection of movement of any objects for security purpose such as to protect indoor areas and some locations where important assets are located like important museums, libraries, etc. So in these areas, high security areas, the microwave radars can be used to detect any movement like objects or human beings. So and also it can be applied to any automotive related application to avoid car collisions. So microwave radars can be employed like this. So this problem we are considering here is the design of a motion detection sensor. So it can be designed for high coupling factor and high directivity to receive the signal very accurately. So for this, an alarm can be triggered by any perturbation of the reflected waves caused by a moving object or by a movement of a body with a radar cross section larger than the prescribed threshold. Because we have to detect the humans but prevent any detection of mice or other things. So we are going to design a motion detection sensor for this application. It is in that directional coupler circuit plays an important role. So the empathy part of our topic is it is to understand the needs of engineers and users. We are considering the following points. So in the engineer perspective and designing the detection sensor, we have to achieve a tight coupling and high directivity for the radar sensor. So compared to the standard coupled line directional coupler in the X band frequency using low cost materials and technology. So in the design perspective of engineers or users, we have to consider this parameter. So the improvement is not straightforward since increasing the coupling factor using low cost material in a far higher frequency range where dielectric and ohmic classes could be critical. So it can be challenging one. So we can apply a asymmetric cascade connection of two coupled line sections. Configuration is able to strengthen the coupling factor over that of a conventional directional coupler. So this is our empathy part where we are going to consider the problems in the design of a directional coupler. And our aim is to design a motion detection system for the detection of movement of scattering objects. So detection of movement usually triggers an alarm or more generally activates other electronic subsystems which will be useful to detect the any substance or object inside the secured areas. So next is our define part. So based on our problems statement, we are going to uh, define some goals and objective for the directional coupler design. So coupled line coupler based on the asymmetric cascade connection of two coupled line section, it will be used to achieve a high coupling factor using the low cost material and technology. So this proposed coupler can be used in Doppler motion detection sensor due to its strong coupling and relatively high isolation. So this will be used to accurate receiver circuits where we can detect the signals easily. And next is our ideate part. So here we are going to implement the ideas for improving the directional couplers. So the microwave part of the motion detection sensor is made by voltage controlled oscillator, a low pass filter and a transmitting and receiving antenna, a mixer and a directional coupler. So that it is required to perform a coherent detection of the received signal. This is our important parameter. The idea going to be included in the directional coupler circuit. It is a coherent detection of the received signal. So it allows a larger receiver sensitivity and larger detection range. So this coupler requires both strong coupling and large isolation. And also it should be compact and low cost. So this is the one of the most critical components of the microwave motion detection sensors. So we can consider the block diagram of a motion detection sensor, where we are using the directional couplers for coherent detection, and it is going to feed the mixer of the receiver circuit. So it will be with high sensitivity and large detection range because of the coherent detection used for the directional couplers, and both transmitter and receiver employ a directional coupler circuit which is based on the microwave Doppler effect. Next is the prototype stage. Here we are considering the design of the directional coupler employed to feed the mixer of the Doppler motion detection sensor. So it is a volumetric X-band microwave sensor which uses the Doppler effect and digital signal processing for external protection. So like all the other sensor using microtechnology to detect the motion, it exploits the Doppler radar principle, where a continuous wave of microwave radiation is emitted by a RF source, and then we receiving the reflected waves. So by calculating the frequency shift in the reflected wave due to the motion of an object toward or away from the receiver, so it results in a signal at low frequency. So this image shows the directional coupler design. So next we are going for testing part. It is based on the previous results obtained from the literature of the directional coupler. So this performance is enhanced by subsequent signal processing, so which after amplification is digitized using an analog to digital converter. So this digital signal is handled in real time by the onboard microprocessor. So using appropriate algorithms, it is possible to measure the distance and mass of the object moving within the detection area. So analyzing all the received data using a fuzzy logic. So we can design and test the proposed directional coupler, and some of the testing parameters are given. So for the coupler design and testing, we are considering the proposed coupler in many different microwave systems. In order to experimentally access the proposal to realize and test a coupler to be used in the X-band Doppler motion detection sensor. So the requirements are, the parameter are coupling that is should be greater than or equal to -7 dB, and bandwidth 10 to 11 gigahertz using the low cost PCB and process. So these are the important parameters while testing the directional coupler. And we are considering the organic ceramic laminate with dielectric constant 3.5 and loss tangent value 0.003. So the dielectric slab thickness was 0.762 millimeter and copper thickness was 35 micrometer. So this is used to design the directional coupler. The smallest spacing available on this PCB with a standard process was 0.15 mm. And next parameter is efficiency testing to evaluate the loss efficiency of the modified coupler. So in order to this, we observe that for a lossless network, the dot product of any column of its scattering matrix with the conjugate of that column is equal to 1. So we are using the properties of the scattering matrix to find the efficiency testing. And next, coupling factor testing. So resulting coupling factor at the center frequency 6.1 decibels is about 2.9 dB stronger than the standard coupler. And next, this coupler designed and realized using a low cost PCB in the X frequency band with the standard technology. So it is used to achieve a stronger coupling over the standard coupled line directional couplers with the same interline spacing. So based on these parameters, we are getting a simple and compact structure compared to other configurations. So with the strong coupling and relatively high resolution, so it will be used to detect the signals effectively using a Doppler motion detection sensor. So we can have a small assessment. What is the use of directional couplers, and what is the empathy in the design of directional couplers? So directional couplers are used for power measurements and also signal detection, coherent detection in the receivers. So it is used to couple a small portion of the signal to the main transmission line, from the main transmission line to the auxiliary line. And also empathy part in the design of directional couplers is we are going to give a high sensitivity directional couplers for the purpose of motion detection sensors in the high security areas, where we can detect the signals with higher coupling and high isolation. And also what is the need for ideate in the design thinking process? So in this ideate process, we are going to give ideas for the implementation of directional couplers. And what is the benefit of testing part? So testing part is used to identify the working of your designed product, so which can be modified if any feedbacks or any defects are identified from the users. We can again we can prototype the required parts, so it is will be very useful. So at the testing part itself we can detect the working, and if anything to be changed, we can change the particular part or working of the device. Thank you for listening.